So let's do some conversions between one pressure unit and another. If you look at your book, you will see what a barometer, the concept of a barometer, what it looks like. So make sure you take a look at the picture and basically how they measure atmospheric pressure and all of that. But let's say you knew that the pressure was 2.50 atmospheres and you wanted that number in millimeters of mercury. How would you do the conversion? Using dimensional analysis, you already know from the previous previous video, that 1 atmosphere is equal to 760 millimeters of mercury. So we're going to use that as our conversion factor. We're going to write 2.50 atmospheres. We're going to do a conversion factor and get millimeters of mercury. Remember, dimensional analysis guides you as to where to put everything. If you want to cancel atmospheres, you put atmospheres down here, and you want to end up with millimeters of mercury, you put it up there. So 1 atmosphere is 760 millimeters of mercury. We're going to go by these sig figs here because this is our measured number here. And we've got 2.5 times 760, and you end up with 1,900 millimeters of mercury. If you wanted to round it to 3 sig figs, it would be 1.90 times 10 to the third millimeters of mercury. Okay, but what I wanted to show you is this setup over here. Very easy to do a conversion. Let's try another problem. Let's say you had millimeters of mercury and you wanted to figure out what the atmospheres are. So let's say you have 625, you know what, instead of millimeters of mercury, I'm just going to write torr, because torr is the same as millimeters of mercury, just to show you torr. And you want to convert that to atmospheres. We already know that 1 atmosphere is 760 torr. Okay, so since we have torr, we want to cancel torr, so you want to put that in the denominator. And then we'll put atmospheres over here. So 1 atmosphere, 760 torr. That way the torr cancels. So get your calculators. 625 divided by 760, and you've got 0 to 3 sig figs, 0.822 atmospheres. Okay? Again, converting from one pressure unit to another should be super easy at this stage of the semester because you've used dimensional analysis for so many more difficult things. So this shouldn't be a problem at all. You should be able to convert atmospheres to pascals or atmospheres to psi. The one you're going to be using the most, honestly, is millimeters of mercury or torr and atmosphere. Those 3 are the ones that you're going to use the most in the calculations. Okay, but you have all of the conversion factors just in case. Okay, so now we get into the gas laws. And the first gas law is Boyle's law. Okay, and what does Boyle's law state? It states that at constant temperature, the pressure and volume of a gas are inversely proportional. What does inversely proportional mean? It means that as the volume goes up, the pressure goes down. As the volume goes down, the pressure goes up. So as one goes up, the other goes down. As one goes down, the other goes up. That's what inversely proportional is, okay? Which kind of makes sense because when you think of pressure as force per unit area, if you take a sample of gas, and this is the same sample of gas, this is N is constant. What do I mean by N is constant? That means it's the number of moles is exactly the same. So the exact same number of moles. We're not changing the amount of gas. But what you're going to see is that if you take a sample of gas and it was, let's say, in a I wish I had some bottles here to show you, but do I have some? Yeah, hold on 1 second. Okay, so I got these 2 bottles here. Let's pretend I have a sample of gas in here, and this is a really small volume, and the gas particles are hitting the side of the bottle, okay? So I have a pressure in here. Now I take all the gas particles, all of the moles of gas in here without losing any, and I pour them into here, okay? Now this bigger volume has all the gas particles that were in here, they're now in this one, okay? But look, there's so much more space, so the gas particles are not hitting the side as much. So that means it's less pressure. The idea is that as you give gas particles more space, more volume, there's less pressure. When you take the gas and you squish them into a really small volume, they're going to hit the side of the container even more, and it will be more pressure. Okay? So, Boyle's law, the temperature is held constant, the number of moles is held constant. The only 2 things that are changing are pressure and volume. The formula or the equation for Boyle's law is P1V1 is equal to P2V2. This is what you guys need to know. For those of you who love derivations, let me just derive this one quickly for you, and I won't derive any of the others. Basically, this is saying that pressure is proportional to the inverse of the volume. So pressure 1 is proportional to the inverse of volume 1. Pressure 2 is proportional to the inverse of volume 2. When you turn a proportionality into an equality, you put in a constant, K. So you can say pressure 1 is equal to K 1 over V. 1. Pressure 2 is equal to K 1 over V2. All right. If you manipulate the equation, put K on one side and P and V on the other, this is going to become P1 V1 is equal to K, and then this one's going to be P2 V2 is equal to K. Well, if this K is equal to this K, and they are exactly the same, it's the same constant, that means this is equal to this, and that is what Boyle's law is. So honestly, this is what you need to know, but I just wanted to show you how they got to it. The concept, you should understand the concept, and you should understand the gas law. So gas laws are really easy math-wise. It's pretty much plug and chug. You're always given 3. 3 are known, and then the 4th is unknown. So for example, I could give you P1 and V1 and P2 and ask you to find V2. It's as simple as that. The only difficult part is just recognizing which one is P1, which one is V1, which one is P2, which one is V2. Okay? Let me go ahead and do a quick problem, and then we'll move on to another gas law. Let's see, I can get one from the book. All right. So a sample of hydrogen gas occupies a volume of 2.25 liters. So hydrogen gas occupies a volume of 2.25 liters at a pressure of 628 millimeters of mercury and a temperature of 35 degrees Celsius. They always give you the temperature, but you're not going to use the temperature for anything here. Then the question is, what volume would it occupy if the pressure becomes, so what's the new pressure? 428 millimeters of mercury. Okay, so look what's happening here. You have a pressure of 628, and now the pressure is lower. So you lowered the pressure. Guess what's going to happen to the volume? Remember how it's an inverse relationship. When one goes up, the other goes down. When the other one goes down, the other one goes up. So if the pressure is going down, the volume must be going up. So you should get a volume bigger than 2.25. Now, what units do we use here? Honestly, it doesn't matter, but the key thing is that pressure has to be in the same units. So if I give you pressure in atmospheres for P1 and for P2, I give you millimeters of mercury, you need to convert one to the other. You can't put atmospheres here and millimeters of mercury here. You have to either have them both in atmospheres or both in millimeters of mercury. That's important. And if I give you, for example, the volume in liters and then this one in milliliters, you've got to convert one to the other. And you know how to do that metric conversion from way back in earlier chapters. Okay, so let's plug and chug here. What I usually tell students is write a little cheat sheet for yourself. Say, what is P1? What is V1? What is P2? What is V2? Okay, write down everything based on the problem. So P1, according to this problem, is 628 millimeters of mercury. What is V1, according to this problem? 2.25 liters. What is P2, according to this problem? 428 millimeters of mercury. And then what is V2? That is my unknown. That's what we're looking for. Okay, so all we're going to do is just plug these numbers into this formula over here, into this equation, sorry, over here. So we're going to write 628 millimeters of mercury, which is our P1, and then our V1 is 2.25 liters, and then our P2 is 428 millimeters of mercury. And then V2 is my X. That's my unknown. So I'm just going to write V2 as my unknown. Okay, so now you just have to do the math, manipulate the equation. I'm going to erase all this now, so I have some space. I divide this side by 428 millimeters of mercury, and divide this side by 428 millimeters of mercury. Okay, cancel, cancel. So I have V2 by itself and all the numbers on the other side. Millimeters of mercury will cancel. I'm going to end up with liters. So now everything in the numerator, press multiply, everything in the denominator, press divide, and you should get the correct answer. Put my glasses back on again so I can see what I'm doing. All right, 628 times 2.25 divided by 428, and you get 3.30. I'm going to go with 3 sig figs because this is 3 sig figs, 3.30 liters. And it's exactly what we expected. The pressure went down, the volume went up. Okay, good. We'll do some more in the next video.